In our previous video, we discussed how students' prior knowledge affects how they learn. Today, we will shift our focus to how students organize knowledge and how that influences their learning. Experts tend to create and maintain complex networks of facts, concepts, and procedures in their field. By extension, such networks are typically organized by domain knowledge relative to specific features, principles, or theories. By creating such sophisticated knowledge networks, experts are able to quickly retrieve and apply vast quantities of knowledge in novel or problem-solving situations. Not surprisingly, students lack the sophisticated knowledge networks that experts have studied years to acquire. This is a function of students having not yet developed the deep connections between various isolated concepts and facts that would allow them to apply knowledge broadly or effectively when asked to. That brings us to the principle associated with today's video. How students organize knowledge influences how they learn and apply what they know. To begin, we need to consider how knowledge networks are developed and organized by emerging or novice learners. The authors of How Learning Works note that knowledge organization often begins in the mold of form meets function. They state that people naturally make associations based on the patterns they experience in the real world. The way that people organize their knowledge tends to vary as a function of their experience, the nature of their prior knowledge, and the role that that knowledge plays in their everyday lives. Research has shown that the usefulness and utility of knowledge networks is dependent upon the tasks that they need to support. In other words, students perform better when their knowledge is well matched with a corresponding task, or they perform worse when there is a misalignment between their knowledge organization and required tasks. What does this mean for instructors? Because research shows that knowledge networks are most effective when they are well matched to tasks, it's important to consider what tasks you will ask your students to do, and to present information in a manner that is consistent with such tasks. By doing so, you can better foster the way that students organize their learning. As noted earlier, one significant way that novice learners differ from expert learners is in the number or density of connections they are able to make between different concepts, facts, and skill sets. Research shows that experts not only have a greater number of connections, but they also automatically process information in larger chunks, and they use such large information chunks to continue to build even larger, more interconnected knowledge structures. Knowing that students lack the quantity of connections between isolated facts, concepts, and skills, research suggests that providing students with a structure for organizing knowledge can be extremely valuable in teaching, particularly when such organization structures are aligned with the relevant tasks to come. One such example is an advanced organizer, which is like an outline with main headings identified, but with space left for students to add their own notes, observations, and personal connections. Not only do novice learners have fewer connections between their various knowledge sets when compared to experts, the connections they do possess are often built upon superficial knowledge rather than on deep knowledge. Experts have an ability to quickly categorize information in meaningful and practical ways, whereas novice learners may notice patterns that are not causal or not as important as other patterns experts might notice. Furthermore, in addition to organizing knowledge around meaningful features and patterns, experts possess the flexibility to use multiple knowledge organization sets simultaneously. In other words, experts have multiple means for categorizing different types of new knowledge with their own prior knowledge. To help students better identify these sorts of connections, it can be helpful to provide students with a practice problem where the answer has already been identified. In this way, students can focus on the process involved in arriving at the answer rather than the answer itself. By imploring students to focus on the connections between facts, concepts, and procedures, students are more likely to discover such deep connections, being unburdened from another task like identifying the correct answer. While far from an exhaustive list of strategies, here are two that you may want to consider adopting in your lectures. 1. Create a concept map to analyze your own knowledge organization. Doing this allows you to orient students to the organizational structures in your domain and to illustrate which principles and features around which you think students should organize their own knowledge. 2. Use contrasting and boundary cases to highlight organizing features. Presenting two such cases together can make differing features more salient and help students develop deeper, more finely articulated knowledge structures. Alternatively, you can provide examples of problems that share deep features but differ superficially, and explicitly discuss with students why such cases are similar despite appearing quite different from one another.